We will start chapter 14 by talking about how chemistry is called the central science, and then talking about the submicroscopic world. So chemistry is defined as the study of matter and the changes that matter undergoes. So matter is anything that occupies space, as we've talked about before: the air you breathe, the seat you're sitting on, the water you drink. These are all examples of matter. Chemistry takes the equations that they figure out in physics and it applies them to matter. It touches all the other earth sciences because those study various subsets of matter. So, for example, biology is the study of living matter. Geology is the study of rocks and mineral matter. Astronomy is studying the matter of stars, the atmosphere, the planets, the universe. There are many other earth sciences, but I think you get the general idea. They're all going to involve matter, and because of that, they often call chemistry the central science. So, in order to find out what we've learned in chemistry, they do research, and there are two types of research that are done. The first is basic research. This just tries to identify a basic principle. So, for example, Einstein established that energy is equal to mass times the speed of light. That's a basic principle. We can apply it to a lot of things, but the discovery of that itself is basic research. There's also applied research. So that's where you're trying to improve something, usually for monetary means, or for improving society at large. So, for example, you could have better products, medicines, fabrics, foods, things like that you're designing using chemistry. Biochemists, here's an example, biochemists have genetically modified foods so that they're more resilient and grow better and have the characteristics that people want. We're now finding that sometimes there are unwanted results from doing this, that you get things like a higher rate of gluten sensitivity when you increase the gluten in wheat. So sometimes what we've done is not a good thing. Sometimes it's been really great because we've got areas where things weren't growing and living successfully that now they are. And so people are eating where they weren't. So there can be ups and downs of applied research, but that's another type of research that they do in chemistry. The submicroscopic world means when you look through a microscope, you can see certain things. What happens when you look beyond what you can see in the microscope? That's submicroscopic. So chemistry is based on 100 types of known elements, and they can be joined together to make an infinite variety of molecules. Those atoms are so tiny you don't see them in a microscope. And when they combine, they can make a variety of things that many times are also not seeable in a microscope. But as we get enough of them together, then you see the matter that's around you. Matter goes in 3 different phases. You're probably familiar with these already. They come as solids, liquids, or gases. Each one has a slightly different setup. A solid is going to build a lattice of your atoms or molecules. And so each one has its little apartment in the whole apartment building. It might move around in its apartment, but it doesn't move to the next apartment. And because of that, you get a very solid structure. It has a definite volume and it has a definite shape. So if I were to take a glass and take a nail is a solid, and I were to drop the nail into the glass, it would still have the same shape. It would still be a nail, and it would still fill the same volume that it filled originally. So moving it from one location to another doesn't change the shape, doesn't change the volume, and that's how your solids work. A liquid, the molecules are attracted to each other, but they move freely. So they slide past each other, they bump off each other. They're not occupying their own little apartment, but they will stay in the same vicinity. They're attracted enough to each other that they stick around. So An example of a liquid would be water. You have water, and if I were to take a cup of water and pour it into a different shaped glass, what will my shape of my water be at that point? Well, it will take on the shape of its container, so it will take on the shape of the new glass. But the volume, how many milliliters you've transferred, doesn't change. It's the same as you transfer it. So your liquids have an indefinite shape. They take on the shape of whatever you put them in, but they have a definite volume. They fill that same volume as you move them from one place to another. Then we have our gases. When you have a gas, the molecules not only move randomly, but they're no longer attracted to each other either. So they spread out so far that they hardly even notice the other molecules are there. What that does is it gives you an undefined volume. So if I were to take any container that's full of gas and shoot it into a cup that I put a lid on, it will take on the volume of the cup, the full volume of the cup up to the lid. If I were to let the lid off, it would disperse out perhaps even more than that. So they expand to fill wherever you put them. The particles also have an undefined shape. If you take a glass full of a gas and you try to pour it into another glass, not only can you not necessarily see anything pour, because it doesn't pour, but you won't be able to see the volume as it goes. You won't be able to see a shape as it goes. So gases just fill what they're in, and for both shape and for volume. Heat causes atoms and molecules to vibrate, and these vibrations weaken the attractions between neighboring atoms or molecules. So if you want to go from a solid to a liquid to a gas, add heat. And they'll shake and shake and shake until they separate out of their apartments, and then they're moving around next to each other, and then they'll separate off to infinity. So ice is solid water, and when it's heated, eventually the attractions are overcome, and you get liquid water. And as you heat liquid water, eventually those attractions are overcome, and you get steam, and it can go out into the air.